Assalamualaikum warahmatullahi wabarakatuh. My name is Zakwan bin Iskandar. My student ID is 2022 491-586.
Assalamualaikum and hi, my name is Nur Safia Idina binti Muhammad Nazli. My student ID is 2022 609 and 524.
Assalamualaikum and hi, my name is Muhammad Danish Ishwan bin Abdul Rashid. My student ID is 2022 863574.
Assalamualaikum and hi, my name is Anis Sofia binti Abdul Walid Ilyas Awalid. My student ID number is 2022 450296.
Let's start this presentation with none other than acknowledgement. We are really grateful for we have managed to complete this video presentation within the time given by our literature, Madam Afiza. This assignment is unattainable without the amazing cooperation and strength of effort from our group members Anis, Zakwan, Safia, and Ishwan. We also similarly, with all of our gratitude, thank our literature of calculus, Madam Afiza, for the guidance and willingness to help us in what we lack while completing this assignment and surely for teaching us this course. Last but not least, we would like to express our gratitude to our family members who keep on encouraging us all the time.
Content prepared in this video going forward includes topic of the title chosen, production of the topic, a problem statement and solutions, conclusion and references towards our study.
The topic we chose is related rates, which is the rates of change. So, what even is related rates?
I know related rates are problems that involve two or more variables that change at the same time, possibly at different rates. If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing.
Why do we even need to use this thing?
It comes in handy when we have two related quantities and one of their rates of change is much harder to find than the other one.
I think I understand it better now. How about we try and solve the following problem below?
A thin sheet of ice is in the form of a circle. If the ice is melting in such a way that the area of the sheet is decreasing at a rate of 0.5 meters square per second, at what rate is the radius decreasing when the area of the sheet is 12 meters square? In this statement, we can first of all find out what it requires from us. As highlighted that here, the keywords are circle, area, and decreasing. Circle means that it uses pi r square for its area, and decreasing means the sheet is getting smaller. Hence, the answer will be a negative.
Let's start solving. Step 1, we will call the area of the sheet as A and the radius as R, and we know that the area of a circle is given, which is pi r square. We also know that dA over dt equal to negative 0.5 and want to determine dr over dt when A equal 20. Note that A is for area, T is for time, and R is for rate.
Step 2 is to differentiate the equation with respect of t, which is time. Pi r square equals to 2 pi r. We do this by referring to the table of derivative of a standard function by replacing x square as r square in x to the power of n, and the answer will be 2 pi r since we minus 1 the power of r square, but also bringing the power in front, turning it into a multiplication of r. These steps are exactly as shown in the table, which is nx to the power of n minus 1. We can ignore pi for this whole time since it is a number, not a variable. And then dA over dr equals to 2 pi r over 1. We put dr as 1 since it is a division. We turn the function around to match what we need to solve the questions as such. We will use equation dr over dt equals to dA over dt multiplied by dr over dA to get the rate.
Step 3 is finding the radius. We know that a equal to 12, hence pi r square equal to 12, making r as the formula, r equal to square root 12 over pi. Radius of the circle is 1.95 meter. Lastly, put all that we have in the equation. dr over dt equal to dA over dt multiplied dr over dA. dr over dt equal to negative 0.5 multiply 1 over 2 pi bracket 1.95 equal to negative 0.04081 meter per second.
In conclusion, the rate of change of the radius for the thin sheet of ice is negative 0.04081 meter square per second. We know that we will use dy per dx as our main equation, and also we can apply the concept of differentiation based on the derivative of a standard expansion table in solving any problem that involves finding an unknown change.
These are all the references used along our study of this work. As you can see, we had also separate YouTube as our inspiration towards this assignment.
Thank you for watching. Bye.